All right, so this video will focus on 7.4, and we're really identifying various polygons today. So the very first thing I want you to do is take a look at these 6 different shapes and try to think about what they actually are. So the first one, if I look, is a trapezoid. I can see that I have 2 parallel sides. These right here are going to be the same length as well. And it's actually made up of 2 triangles and then a square in the middle, right? This one here is a parallelogram, meaning it has just the 4 sides that's parallel here. This is parallel to this side here, and then these are also parallel. So I'm going to quickly draw this out. So this is parallel to this side, and this side is parallel to this side. This one here is going to be a square. I have my 4 right angles, and then all the sides are equal to each other. And the way that I denote that, which I just did a moment ago, is this side is equal to this side, which is equal to this side, which is equal to this side. And they're all right angles here, right? So I have this little square here. This is the proof. This here is a rectangle. So I have my 90-degree angles that I had before. So that's still the same. Sorry, that was supposed to be a square. And then I have this side here is congruent to this side here, and this side here is congruent to this side here. So if you think about it, a square is technically a rectangle, right? I mean, I have the various sides here that are 90 degrees, and I have this side, and these sides are equal to each other. So a square is a rectangle, but a rectangle is not necessarily a square, because the same properties that need to be a square, they all have to be the same size. So if the rectangle has different side lengths, it is not a square. This here, of course, is a triangle, and this here, there's 5 different things. So this is in Washington, D.C., there's the Pentagon, and that's what it is. So really what we're doing is how could you classify quadrilaterals? And we'll start off with this here. And I have this very first one. And if you look, I have 4 sides all that are congruent to each other, meaning they're the same length. And if I look, the angle measurements are the same here and the same here. So those are vertical. And then this here is also the same as up here. So this is a rhombus when you have this. This one here we mentioned before is a square because it has 4 90-degree angles and all the sides are congruent. This one here is a rectangle because I have the 4 90-degree angles. And again, if I look, I have this side's congruent to this side, these 2 are congruent, so rectangle. Now this one here, if you look at it, I have 2 parallel sides, parallel, parallel, no 90-degree angles. So this is a parallelogram. This one here is where I have my 2 parallel lines with my little diagonals. I can make the triangles and the square in the middle. Let me show you what I mean by that, by the way. I would go straight down and drop a line, and then drop a line. That's a little off, but you get the point. So I have my square, and then my 2 triangles on the side. That's a trapezoid. And then finally this one here. So I have this measurement is congruent to this measurement here. And then these 2 are congruent to each other as well down here. So this is called a kite. And those are really the ones you have to have mastered for the test. So if I look here, I want to classify this quadrilateral. Again, it has this quadrilateral, meaning 4-sided shape, has 4 congruent sides and 4 right angles. Well, if it has that, that's definitely a square. This one here is a quadrilateral as well. I have 2 congruent sides, so this one here and this one here, and then these 2 are congruent as well. We saw this before. This is called a kite. So again, the thing that really makes this true is it's a quadrilateral and 2 pair of congruent adjacent sides. So they're right next to each other. This side length and this side length are the same length and they're next to each other. Whereas this one here and these are adjacent as well. So we'll classify this one here. So I have all 4 sides and they are all congruent to each other, right? But the measurements are not 90 degrees. So this is called a rhombus. This is where it's kind of a square kind of pushed over in a sense. This one here is that whole triangle thing, where I have the congruent sides on over there, and that's going to be called a trapezoid. And then finally this one here, if I look at it, my 4 right angles, and then this side being congruent to this one, this is a rectangle. So what we basically want to know is with all quadrilaterals, meaning all 4-sided shapes, the total angle measurement inside is equal to 360 degrees. So when I add up everything, it's just like the triangle, only instead of having 3 things, I have 4. And because I have the 4, it equals 360. It's like a big circle all the way around, right? So now let's try doing one. So if I want to find the value of x, I'd have to add up these three measurements plus x, and that would equal 360. Looks like this. I then combine like terms. Plus x equals 360. So I have 260 plus x equals 360. I now have to subtract the 260 from the left. From the right, I'll have x equals 100. And that is my answer. If I put 100 up here, it will then be all four measurements, right? So the value is 100. So it says to draw a parallelogram with a 60-degree angle and a 120-degree angle. So that's 180 so far, right? So I could actually draw like maybe a kite. That would work out well because I want to have the exact same measurements again. So I have 120, 120, a 60, and a 60, and that should equal 360. In this case, they made a parallelogram. Totally fine. Again, I have my 120 degrees here, my 60 here. This one, which is a vertical angle directly across, is going to be 120 up here, and this is 60. So if I add them all up, I should get 360. And then finally, I have these down here. So what is the value of x? Of course, I add them all up. Has to equal 360, so it equals 80. This one, when I add them all up, should equal 65. And this one here says draw a trapezoid. So again, they have two parallel lines, and 3 centimeters for one and 5 for another. And then I connect it, and this is considered a trapezoid. It's a right trapezoid because it has a right angle on it. And that's